Today is the official start of our trigonometry unit of IB mathematics. This would be topic 3. Yeah, I think it's called topic 3. But anyway, IB refers to these things as the circular functions. If you were already in a pre-calculus class, I have good news for you. IB trig is only sine, cosine, and tangent. That's it. And we only graph sine and cosine. We don't even bother graphing cotangent or graphing tangent. Sine, cosine, and tangent, and the only graphs we mess with are sine and cosine. It's just that IB doesn't really care much about the tangent graphs, and the reason why is because they're not insanely useful in the real world, the graph of it. Whereas the sine and cosine graphs actually do a lot for us in the real world. Tangents, not so much. I mean, it has a few uses. I have looked into it. I don't remember what they are, but I have looked into it. But we will be stretching your knowledge on how to use trigonometry, because I mean that's what IB is about, right? IB is all about problem solving and using skills. So we'll begin our circular functions unit topic in unit 8. We begin with radian measures. And you're going to want to pay close attention, because if you're the kind of person that still thinks in degrees, it's time to change your mind. A radian is an angle that is centered at the center, go figure, of a circle, and the angle's measure is equal to the length of the arc it creates. That's a little confusing, right? What I just said. An angle's measure is equal to the arc it creates. Okay, so let me draw it. Let's just say I have an angle, and a radius, and let's say that that radius is length r. Right? I don't need to have an actual number for it, okay? Let's just say it's the length r. Theta is the Greek symbol we often use for angles. It's not the only one, but it is the one that I'll use the most often. So what I'm saying is this is the center of a circle, and this would also be a radius. Radii go to the edge of the circle, yes? Okay. Edges of circles are not straight, are they? It's curved. A piece of a circle is called an arc. Does that make sense? Because it's a curved line? Yeah? And can we agree that if I cut a piece of a circle off, I should be able to measure it? It should have length. Can we agree to that as well? Okay. So here is the arc of the circle. And what I'm going to say is that its length is also r. So if you have an angle created by radii that create an arc that has exactly the same length as the radius, then we would say that this angle is 1 radian. That's what a radian is. It's somewhere around 36 degrees-ish, but that's what they are. Now, as it turns out, if you were to take this radius and you go, well, look, I know that the circumference of a circle has to be related somehow to that radius, right? I mean, clearly, the radius is what creates circles, right? I mean, the size of a circle depends on the size of the radius. So clearly, the length around, almost like the perimeter of a circle, must be related to the radius. So mathematicians realized this long time ago, and they go, okay, let's see how many radius it takes me to get around the circle. How many of these arcs would it take for me to go all the way around this circle? And they, laid them on the ground or whatever, however they did this, and they counted like, that number's not pretty. Let's change the size of the circle, which means I changed the radius. Try it again. It took the same number of radius to get around this thing. Strange. Well, as it turns out, going around a circle every single time takes a little bit more than 6.28 radiuses. Anybody know the significance of the number 6.28-ish? It's 2 times pi. That's how pi was discovered. It's the number of radius that it takes to go around to a whole circle is the number 2 pi. It literally means 2 pi radii. That's why the circumference formula is 2 pi r, because it always takes exactly 2 pi of those radiuses to get around. Now, if we're talking about a unit circle, that means this radius is 1, which would mean that your circumference around your circle is literally 2 pi. The angles then are called radians because they create this curved radius, and there are always 2 pi radians in a circle. So 2 pi radians is 360 degrees, which means 180 degrees, or half a circle, is pi radians. Does that make sense? Now, I do want to talk real quick about radians and degrees. Did you see that I was able to explain to you what a radian is without having value for this radius? And I told you, regardless of the size of the radius, it will always take 2 pi of those radii to get all the way around your circle, which means there will always be 2 pi radians at the center of the circle that make it up. How many degrees make a circle? 360. Why? Why is it 360? I mean, because I can tell you why it's 2 pi radians to get around the circle, because it literally takes just over 6.28 radius to get around that circle. But why is it 360 degrees? I know the answer why. You want to know why? Because we said so. It literally has no mathematical reasoning behind it, other than the fact that 360 can be subdivided by a lot of numbers. 360 can be divided by 1, 2, 3, 4, 5, 6. Does 8 go into it? 8, 9, 10, 12, like 300 on of 15, like 18, 20. I mean, I don't know them all, but 360 can be divided by so many numbers. It's like one of these magic numbers where it's just got tons of factors. That's legitimately why mathematicians just said, screw it, let's call it 360 degrees. And that's the only reason why. That's also why there's 60 minutes in an hour and 60 seconds in a minute. Because 60 times 60 is 360. That's why. Okay. Because honestly, we could have subdivided our time in any one way that we felt. They just went with 60 because they'd already decided that a circle was 360 degrees. So they said, okay, we'll call it 60 minutes and 60 seconds. Done. Ta-da! That's legitimately where that stuff comes from, which is really neat. Anywho, what I'm getting at here is radians are the way to go when you're talking about measuring circles, not degrees. Degrees suck, radians, awesome. Okay? The faster you can change your mind from thinking in degrees to thinking in radians, the happier you will be in trig land. So what we need to learn how to do first and foremost is convert between degrees and radians. And we're going to have to use a little bit of everybody's favorite thing from physics and chemistry, dimensional analysis. Unit conversion. You know, like converting feet to inches and things like that. Only we're going to be converting degrees to radians and radians to degrees. The way we do that is by using the fact that it's 180 degrees in pi radians, which we'll shorten that to rad. And actually, the way it works in trigonometry is if you don't see this degree symbol, it's automatically radians, automatically. So you don't even have to use the word rad. You can just be like 3, and the assumption is that's 3 radians. Cool. We know that there are pi radians for every 180 degrees, which means there are 180 degrees for every pi radians. So when we're converting, we'll use one of these two fractions to convert backwards and forwards. Start with 45 degrees. It says convert it to radians in terms of pi, meaning I want a pi in the answer. Don't use the pi button on the calculator. That's what that means. So we say 45 degrees, and we're trying to convert it to radians. In order for my answer to have radians at the end, I need radians in the numerator. So I say pi rad over 180 degrees. Legitimately, the units cancel like their values. Dimensional analysis. That's going to give us 45 pi, and just assume radians because I didn't write degrees, over 180. Anybody know how many times 45 goes into 180? Goes in 4 times. Because 45 plus 45 is 90, and 90 plus 90 is 180. So it's pi over 4 radians. 45 degrees is pi over 4 radians. Okay. Convert 126.5 degrees to radians, also with a pi in them. So again, because I'm going to be trying to get rid of degrees, I need degrees in the numerator. I don't feel like writing rad, so I'm just going to write pi. It's assumed. And you get 126.5 pi over 180. And I don't remember what that is as a fraction, so I'll be waiting on somebody to tell me. I thought I heard calculators. I guess I didn't. Ooh, it's ugly. It's not pretty. So I'm going to leave it in terms of pi. I could double the top and bottom and get 253 pi over 360. But 253 is not divisible by a whole lot of things that I know of. That looks good. Whatever. I don't know. Let's see. 1260 divided by 1800. Oh, 1265. That's what I meant to do. Yeah, it's. I don't think 253 has very many factors, so we're just gonna leave it like that. Don't worry. There will be some very special ones that you'll need to have known by heart. This is one of them. That 45 degrees is pi over 4 radians. That's one of the ones you'll have to know by heart. And this one will be too. 5 pi over 6. So this is in radians. And since I'm trying to get to degrees, that means I need to be able to cancel out my pi radians, right? So that means the multiplier had better have the pi radians in the bottom. So 180 degrees goes on top. The pi's cancel out. Those are actually numbers. They're not even units. They're legitimately numbers, pi. And you get 5 times 180 divided by 6. Or you could say 180 divided by 6 is 30. So this is 5 times 30. 150 degrees. And if it was me, I would have done it even faster. I would have said, oh, pi radians represents 180 degrees. 180 divided by 6 is 30, and there's 5 of them. Just like that. I wouldn't even bother doing this. I just said that represents 180 degrees. That goes in 30 times 5. Yeah, this is it. Starting off easy peasy. And last but definitely not least, it says convert 0.638 radians to degrees. 0.638, I don't need to write radians, it's assumed, but if I'm trying to get it in degrees, that means I need 180 degrees over pi. And for that one, we grab handy dandy calculator because I have no clue what 0.683 times 180 is, especially divided by pi. 0.638 times 180 divided by, and pi is right there above the caret. So second caret. I don't know who named it caret, but that's what it's called. Equals. Oh, about 36.555 degrees. My phone is ringing on the video. Isn't that just lovely? Because 0.638 is a number of radians. When you say 2 pi radians, you're literally saying just over 6 1/4 radians. Okay? Pi is a number, not a unit. And that's going to call it. Oh, yep. So, meaning if it says, like if I said 2 radians, not 2 pi radians. If I just said 2 radians, that means 2 of the angles that create an arc length that have the same length as the radius. So 2 radians would be 360 divided by pi. and I don't know what that answer. It's like 72-ish, I think. But so 0.638 is a number of radians. It literally means less than 1 radian, whereas pi radians means 3 and change radians. So start thinking of pi, it has a numeric value. No, 5 pi radians means 15 and change radians, 3.14 times 5. When you say pi radians, you're saying a number of radians, where a radian is a type of angle. Okay? Okay. Her okay sounds like no.